of 5.3. It's actually part 2. And so again, we're still working on solving trigonometric equations using basic identities. Yesterday was algebraic techniques. You had it to one function, or with factoring, you had one function as a factor and another function as a different factor. You can set them equal to 0 and solve. But today we're actually going to use some of the identities because it's not going to have one function. Our goal is to try to get it to be one function so that we can evaluate it. Or, again, two functions that were factored, like the problems we saw, I don't even see my scrolling bar, at the bottom of this page. So our first, that's going to be a problem. So our first problem, we have a story problem. The baseball leaves a bat with an initial speed of 30 meters per second and clears a fence 90.5 meters away. The height of the fence is the same height as the initial height of the batted ball. If the distance of the ball traveled is given by that equation, where 9.8 is in meters per second squared, find the interval of possible launch angles of the ball in degrees. So we're finding the angle. So we're going to use some of the techniques that we did yesterday, and actually a lot of the techniques we did yesterday, because it's in terms of sine. It's only in terms of one trig function. But I have to plug in the distance first, d, and I also have to put in the initial velocity. The distance right here, 90.5 meters away, that's our d. And then the speed is 30 meters per second, so that's the velocity, and it's supposed to be squared. So we have 30 squared times sine of 2 theta over 9.8. And 30 squared is 900. So we have 900 over 9.8, and then times sine of 2 theta if I want to rewrite this. 900 over 9.8 times sine of 2 theta, and we will need a calculator because we're going to have to multiply by the reciprocal of that value. Thank you. So on the calculator, we're going to do 90.5 times 9.8 over 900. Oops, I didn't put it in right. So this, I'm going to try to convert it to fraction. I highly doubt it's going to. Yeah, that doesn't help me much. Not on our unit circle, right? So we have 0.9854. I wanted to go at least 4 decimals out because it's not my final answer. That's the equivalence of sine 2 theta. Nope, that's not it. I could either take it out 4 decimal places, or I could actually write out the fraction. I think I wrote out the fraction before. That made more sense. That's fine. Fraction would probably be more accurate. Actually, I'm going to write out the fraction because it's going to be more accurate. Hold on. Which was, wait a second. Did I do this wrong? No. Okay, I'm going to go back a step. Instead of multiplying by the reciprocal, I'm going to multiply by 9.8 and then write over 900 because it'll have a decimal. That makes sense. So we're going to do this. We're going to go back here, do 9.8 times 90.5 and put that over 900. It's not gonna help us times 90.5. It's not going to help us in terms of the unit circle, but at least it gets us to a more accurate answer. So we have 886.9. And then instead of dividing by 900 in the calculator, I'm just going to write it like this. Equals sine of 2 theta. We'll have to figure out what the angle is first, and then knowing that it's 2 times that angle, we'll have to divide by 2, or what the possible angles are first. Now, your calculator is going to be used as a tool, but does your calculator find all the angles from 0 to 2 pi?
Yes.
When you do the inverse? No, it only finds them in which quadrants for sine inverse? 1 and 4. 1 and 4. Because remember, for the inverse, when we're just evaluating what the sine inverse is in terms of a function, it's from negative pi over 2 to positive pi over 2 for the outputs. We restricted the domain on sine so that we could actually map it to only have one output for each input when we do the inverse. So it's only going to give you one of them. Guess which one it's going to give you?
Quadrant 1.
The positive answer for this problem. So we're going to do sine inverse of that in our calculator right now, and then we're going to have to remember that, wait a second, there is another one on our unit circle somewhere, and I have to figure out where that is. 86.9 divide, oh, I have to do sine inverse of it. Second sine inverse of 886.9 divided by 900, and that's 80.2, 80, we'll do the nearest 10, 80.2, actually it says, doesn't say. So we'll say 1 of our 2 theta equals 80.2, is that what it said? Yeah, 80.2 degrees. Well, that's 2 times theta, so we'll have to find theta in a second, but we know in our unit circle that sine is positive in more than just quadrant 1. It's also positive in quadrant, negative in quadrant 4. Quadrant 2, it's also positive in quadrant 2. So right now I have 80.2 degrees, in quadrant 1, and sine is also positive in quadrant 2. Since this ratio was positive, that's how I know that that's what I'm looking at, is the positive values for sine. So that means that over here, it would be the same. How am I going to get that angle?
180 minus 80.2.
180 minus 80. So I'm thinking that might be right. Let's take a look. Theta prime, our reference angle, was 180 minus theta inside, or when I knew the big angle that was in quadrant 2 and I was trying to find an angle in quadrant 1. So to reverse that, yes, you're right, we're just going to subtract 180 minus 80.2, which is 99.8 degrees. So 2 theta is also 99.8 degrees. But that's 2 theta, so what do I have to do to these?
Divided by 2.
Divided by 2. So that gives us final answers. Let me erase this over here. That theta is either 40.1 degrees or 49.9 degrees.
Where'd you get the 40?
He divided the 80.
Dividing the 80.2 by 2, because it was equal to 2 theta. Dividing the 99.8 by 2,
Okay.
because it was equal to 2 theta. Yes?
Sine inverse of this.
I mean, every problem is going to be a little bit different, but for problems like this that have a formula, you're going to find out what information you have to plug in, and then you're just trying to solve to find whatever it is. And in terms of this, we're working with trig functions. That's why this problem's in this section. So we're trying to get the trig function by itself. If it's something that's on our unit circle, cool, we can just go from 0 to 2 pi like we did in yesterday's practice. But it's not on the unit circle, so we have to use the inverse in the calculator. The problem is it's only going to give us one of those values around the unit circle. And for sine, it's going to be somewhere in here. And for tangent, it'll be somewhere in here. For cosine, it would be somewhere in here. And then we just have to work to say, okay, wait, sine was positive in these quadrants, or sine was negative in these quadrants, and figure out where the other one is. For this one, it is because they said find the interval of possible launch angles for the ball. Okay, so those are the 2 ones that match this equation exactly. There could be a range within that would work too. Yes. I multiplied 90.5 by 9.8. Oh, good, it's back. All right, Pythagorean identities. You should be very familiar with these because you used them a ton. Any questions, though, on the previous problem? All right, guys.
Are we gonna have like practice with them?
You're going to have practice problems like that, yes. All right, so let me erase part of this just to put the Pythagorean identities there. You already know them. What's one of them? Sine squared plus cosine squared equals 1. And all the others can be derived from that.
Yeah.
I'm not sure, gentlemen, why you're still talking, because it's picking everything up. I shouldn't have to say it for a second day not to talk right now. You normally wouldn't do that while I'm giving notes and not recording. Now I'm recording and you're doing it. Both of you can stay after class today. The other ones, we have tangent squared plus 1 equals cotangent squared. And what's the other one? Secant squared, okay, that's a variation of it. Cotangent squared plus 1 equals secant squared. Some of you, because you use the other things so much, you start with a different one, that's okay. You can start with any one of the 9 as long as you have a relationship between secant squared, cotangent squared, tangent squared, sine squared, and cosine squared. You've got a way to figure it out. Find all the solutions to each equation over that interval, so we don't have to do the whole plus 2 pi or plus pi if it's in terms of tangent or cotangent.
Isn't the notes tangent and secant together?
Did I write them wrong? Oh my gosh, yeah, they're written wrong. Wow, I wrote them wrong on here, so I copied it wrong. Or I wrote it wrong before. All right, so yes, this is secant squared, and this is cosecant squared. Thank you. That's important. All right, so the reason we're going to be using our identities, and some of the other ones that used as well could be used, is to solve these. I either have to be able to factor them into factors, but each factor has to have its own trig function. Or I just have to have one trig function in the equation. And right now I have 2 trig functions in the equation, and there's no way to factor it out, that it's just gonna, I can't factor by grouping or factor in a way where it's gonna work out to have those equal to 0. So I need to rewrite them in terms of one function or the other one. Since this is the one that's squared, I'm gonna rewrite this as 2 times 1 minus cosine squared of x. And that's gonna be 2 minus cosine squared of x. So I'm gonna subtract the 2 and add the cosine squared, because just like x and x squared, this is a quadratic. We have a cosine squared on one side, and we have a regular cosine on the other. So we gotta get everything to one side, get it equal to 0 and factor.
So you didn't mark like 2 cos.
Isn't it 2?
It's 2 cos, yeah, I didn't distribute the 2 thing. So now I'm gonna move those to the other side, add the 2 cosine squared. We have a minus cosine, subtract the 2, 1 minus 2 is an sine squared became 1 minus cosine squared. So we're using the identity to get it in terms of one trig function.
Wait, what is COS?
That's supposed to be COS. Cosine. So now I can factor this, and if you don't like cosine, you can replace cosine x with a variable. You can treat this as 2y squared minus y minus 1, and then once you have it factored out, put it back in terms of cosine. This is going to be 2 cosine. Cosine. And I'm going to have plus 1 and minus 1 for them to multiply out to have the middle add up to -1. So now I have each of these factors equal to 0. No, because we added it to the, here's my equal sign, so I added it to the other side. Yeah. So if I solve this by having this one equal to 0 and this one equal to 0, this one's going to be 2 cosine plus 1 equals 0, which means cosine is going to be subtract 1 divide by 2. That's cosine of x. And I'm going to have 2 locations on my unit circle from 0. By the way, yesterday in our notes, remember how somebody said, oh, we got to do 2 pi, and I didn't look at it because it was above the screen? We should not have included 2 pi because of the bracket that was on there. It was a parenthesis, which meant from 0, including 0, up to, but not including 2 pi. So we might want to go back and fix that in a little bit. All right, so this one for cosine of x equals -1/2, that's going to happen at 2 pi over 3 and 4 pi over 3. Yes, because it's on an interval, I don't have to account for all revolutions of it. And the other one, cosine equals 1. Cosine equals 1 at only one place, and that's at 0.
Or 2 pi?
Hmm?
Can we do 2 pi?
No. If it were 0 to 2, that's the mistake we made yesterday. If it were that, then we would include 2 pi also. We should not have included 2 pi yesterday because it's this, which means up to but not including it as part of the domain. So here are our answers for x.
Our answer's always gonna be in radians.
It will be for now, yeah, because we're getting all of them off the unit circle. Yes, it should be, when we're in pre-calc and higher, it should be in radians unless the problem started out in degrees or there's an application where they say they want it in degrees. All right, find all solutions of each equation on a single interval.
You skipped it.
Hmm?
You skipped it.
I skipped something? Oh, I skipped this one. All right, what trig function? I guess it doesn't really matter which one we go to, right? I think I'm gonna put everything in terms of cotangent. You're gonna get the same answers either way. If somebody wants to do it in terms of cosecant, you can. I'm gonna do it in terms of cotangent though. So we have cotangent squared times 1 plus cotangent squared. Is that right?
No,
No, it's 1 minus.
it's 1 plus 1. Cosecant equals 1 plus.
Cosecant is 1 plus tangent squared, yep. And then we have plus 2 times 1 plus tangent squared. No, that's not, it's not, it was cotangent, because that would be, yeah. Right, where is it? Cosecant is cotangent, it is, because they're both divided by sine. Right, cotangent is over sine and secant was 1 over sine, so yes, it is cosecant. So it would be, this is 1 plus cotangent then, right?
1 minus.
1 minus, hold on, let me look back up here. That's what I had written down, but then I thought,
No, it's
That's
1
wrong.
cotangent plus
no,
1.
cosecant squared is cotangent plus 1, right?
Oh,
Right, hold on. I started by dividing this by sine. Yeah, that's right. There's the plus 1, there's the cotangent, there's the, oh, divided by sine squared. So yes, it's right. It's supposed to be 1 plus cotangent squared. 1 plus cotangent squared, and right now it equals 2. You're gonna have to distribute those in. You're gonna get cotangent squared.
you forgot a minus.
What did I miss?
A minus.
Minus cotangent squared, that would have been helpful. Thank you.
Don't you subtract 2?
Not yet. I can. I will have to, yes. You could do it now, but I'm just going to distribute this for now. I've got cotangent squared plus cotangent to the 4th. That part's not so fun. Plus 2 cotangent squared minus cotangent squared equals 2. This is going to be, I'm just going to take this one off. It's just easier. So I've got cotangent to the 4th. I could minus 2 if you went now. Could have done that later though, but that's going to just get rid of it on this side. Cotangent to the 4th plus 2 cotangent squared equals 0. Any questions on that? I should have probably just left the 2 and then subtracted it in a minute. Well, this isn't going to be too bad to solve, right?
Divide by 2.
I can't divide. Remember, I can't divide by a function.
Take out.
But I can factor out a cotangent squared, which leaves me with cotangent squared plus 2. So this means that cotangent squared equals 0, which when you take the square root plus or minus square root of 0 is 0, so cotangent of x equals 0. And here, if I add or subtract 2, I'd have cotangent squared equals negative 2. Uh-oh.
So solution.
Well, we've got, then we got cotangent equals plus or minus the square root of 2i, right? Or 2. No, sorry, negative 2, which is plus or minus I squared, so 2. Do we have a way to evaluate that?
Nope.
Nope. So that part leads us to no solution for that part. Cotangent squared equals 0 does have a solution though, yes.
When I was doing last night's homework, like some of my solutions were like that, or they were like not on the unit circle at all.
Yeah, I got it.
Yeah.
Okay.
So
So if they're not on the unit circle, then we have to do, and we'll go over them in a minute, what we did here,
Okay.
which is use your calculator to evaluate it. It's not on the unit circle, but it's only going to give you one answer, right?
Yeah.
So then you have to figure out what other quadrant is sign positive or what other quadrant is sign negative if it started out as negative.
Okay.
And then we work our way back to that. So with this though, that means we have cotangent of 0. Cotangent is cosine over sine. That's going to happen at pi over 2. And 3 pi over 2. I almost stopped at pi over 2 and added the plus pi times n, but we're not doing it for all revolutions. We're only doing it from 0 up to 2 pi. So there's our answer for that. Any questions on that problem? All right, last example, well, sort of, close to last example. Edit, clear, ink. All right. Well, we have a problem here. Neither one of them squared.
Oh, looks like we can change that. It's just square term.
I could square them both, right? You can square both sides of an equation. Yeah, you can do that as long as whatever you do to one side, you do to the other. So this is tangent squared, good suggestion. And this is secant of x plus 1 times secant of x plus 1, which is then secant squared plus 2 secant x plus 1. Well, which trig function should I move these to? Should move everything to secant because these are, I've got a regular secant, not just a secant squared. So I'm going to make this 1 minus secant squared. And secant squared minus 1, right? Secant squared minus 1. So now I'm going to subtract the secant squared, which is nice. And add the 1, so I have 2 secant plus 2 equals 0. Well, now I don't have to factor because I just have one trig function. Subtract 2 divided by 2, secant of x is negative 1. You can factor out the 2 if you want to. It's not really going to help much. So secant, I'm going to flip this to 1 over cosine, or actually I'm going to flip it to cosine by flipping the fraction. This was negative 1 over 1. Now it's 1 over negative 1, which is the same thing. So I'm looking to see where cosine is negative 1, and that happens only at pi. So theta equals pi, or x equals pi. Try the next one. See what you get for letter B.
Would it have worked out as
You wouldn't have a way to change tangent to secant because the figure and identity only works when it's squared. So you do have to square it. Yeah.
Okay.
I guess we could have tried to do a trig proof and like made that sine over cosine.
That's actually
But it would have gotten a lot uglier. And, like remember, yeah, this is a much more efficient way.
Okay.
That's usually what they tell people who need blood. I know. I don't know why they stopped. They must be waiting for your blood test to come back to make sure it's. Just kidding.
Probably don't.
Do we have any answers yet, or no? Cosine squared equals sine squared x minus 2 sine x plus 1. This becomes 1 minus sine squared worry, some of you are getting answers. I'm not putting up there yet. Well, gee, you know what would be really easy to do right now? Did you guys get this? Yeah, I should have gotten that so far, right? Some of you are further than that. What can I do with the 2 if I don't like it? Factor it out and divide, right? Did I subtract? Oh, it was supposed to be subtraction of 1. Whoops. Thank you. So it shouldn't be plus 2 because when you subtract this, yep. I can still, if I don't, I can take out a 2 sign. If I don't like the 2, I can factor out the 2 and get rid of it because it's equal to 0. But actually, I do want the 2 sign. That's a good point because I want to get it to factors. So, because it's a quadratic. So this will be sine minus 1. So now we have, for this one, sine of x equals 0.
No, you just take out sign.
I did take out sine.
Why didn't you take out 2?
Wasn't there a 2 here as well?
Yeah.
Yeah, I just erased it by accident, sorry. So now I have sine equals 0 and sine equals 1. Sine equals 0 in 2 places, at 0 and pi, and sine equals 1 at pi over 2. So there are my 3 answers. I don't have to worry about adding 2 pi n to it because it has a defined interval. It's not for all revolutions. The assignment that goes with this section, then we're going to go over questions that you had from yesterday, is on your assignment sheet, but it's page 331, 19 to 30. All right, get started. We'll go over the homework questions in just a second.